Ever get charged twice for the same thing? Or see your Uber driver's name change mid-ride? It's not a bug, it's a bad database design. Behind every confusing, slow, or broken app, there's probably a database screaming for help. In this video, I'll show you the 5 goals every great database must achieve, and why ignoring even one of them can cost your user money or worse. Let's start with data consistency and integrity. Data consistency means information in your database doesn't conflict with itself. Data integrity means information is accurate, complete, and follows the rules you have set. In combination, these two terms are about defining appropriate data types, constraints, and relationships among entities to ensure that data remains consistent across different tables, data redundancy is minimized, and anomalies are prevented. For example, given two related entities, it's better that they are represented using different tables, and they don't share more columns than the primary/foreign key. Otherwise, you will have redundancy issues as well as insert or update anomalies. Such issues can have real impact on real world. Think about when you order a laptop online. The confirmation page shows that the price is $1 short of $1,000, but your email receipt says it's actually $1,199. Issues with data consistency and integrity can instantly break trust and causes confusion, even in something as routine as online shopping. The second goal is maintainability and ease of use. Maintainability means your database is easy to update, fix, or expand later without breaking everything. Ease of use means it's simple for developers and analysts to understand, write queries, and get the data they need from your database. In short, a well-designed database should be intuitive to use and easy to maintain by the people who use it, including database administrators, analysts, and developers of the web or mobile applications that are powered by the database. A lot of measures can be taken to increase the maintainability of a database. For example, following a constant naming convention is a small thing to do when you design a database, but it can save a lot of time for people to use it or maintain the database in the future. Imagine that you are a data analyst or database admin, and you have to maintain a database with this issue, where IDs are used inconsistently in the database. For example, in the product table, it's product_ID. In the review table, you have a snake case, that's review ID, where I is capitalized. If developers who use a database have to spend time figuring out whether and how ID or identifiers are used as a primary key column, the database is hardly intuitive to use, let alone easy to maintain. The third goal is about performance and optimization. Performance means your database responds quickly, even when handling a lot of data. Optimization means it's designed in a smart way so that it doesn't waste time or resources when running queries. In short, a well-optimized database should give you the right data fast, whether it's one user or a million. You can take different measures to improve the performance and optimize your database. For example, indexing is a common technique to optimize the database performance. Think about the review table in a database supporting an online store. The data in the review table often needs to be sorted by date, because potential customers often want to see the latest review of a product that they are browsing. To speed this sorting process, you can index the date column in the review table. So what's indexing? Think of the data in the review table as a library of books. Indexing is the process of creating an index card catalog that lists every book alphabetically along with its location. When you need to sort, you can use the index card catalog to locate every book and put it in the sorted position. This procedure will speed up the sorting task whenever it's needed. The next goal is about data security. Data security means protecting your data from unauthorized access, leaks, or tampering. Only the right people should see or change the data, and no one else. It's about keeping sensitive information safe, whether it's a user password, medical record, or payment detail. you will need to take different measures to secure your database. For example, if you ever need to store payment method information in your database, you should store only encrypted information. Storing customers' payment method information in plain text is a bad idea. If an evil hacker gains access to the database, they will know everybody's credit card number. And that's exactly what happened with Sony PlayStation in 2011. When the server of PlayStation was hacked, hackers stole personal information from 77 million user accounts. Sony admitted in testimony that part of the credit card data was stored unencrypted in many cases. Failing to secure the database has grave consequences. In this case, the estimated loss was over $170 million, and the entire PlayStation network had to stay offline for 23 days to strengthen its security measures. The last goal is about scalability and flexibility. So scalability means your database can grow, it can handle more users, more data, and more traffic without slowing down or breaking. Flexibility means that your database can adapt when your app or business changes, like adding new features or storing new type of data. A good database design makes it easy to grow and change without starting over from scratch. You can take different measures to enhance the scalability and flexibility of your database design. For example, you can implement a cache mechanism for frequently accessed data, such as the product information in the database of an online store. Caching involves storing frequently accessed data in fast access memory, such as RAM, which can significantly improve database performance and responsiveness, particularly as the data size grows. There are many popular caching mechanisms, such as Redis and Memcached. In this video, you'll learn about the 5 goals database design should strive to achieve. If you find this video helpful, give it a thumb up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You can find the link to the book in the first comment.